All right, greetings everyone. The purpose of this video is to go over some additional examples of set operations as well as cardinality, how they relate to when we're given the actual elements in the set, but also when we're representing them with Venn diagrams. So we're going to start with this example you see in front of you, which tells us that we have a universal set that is 1, 2, 3, and then the ... tells us we fill in the blanks there with all the numbers all the way up to 10. So we're basically looking at the whole numbers 1 to 10. The set A are the elements 1, 3, 5, 7. Set B is the elements 1, 2, 3, 4. And the set C are the elements 3, 4, 6, 7, 9. And we're asked to figure out the set represented by A union B intersected with C complement. Now, to start a problem like this, we begin it much in the same way that we would begin a algebra problem or an order of operations problem that involved parentheses. And that will start with what is inside the parentheses. So we're first going to figure out what A union B, what is in that set. Now recall that A union B means that anything that is in either set, we just don't write repeats. So if I look at the sets A and B up above, I see first of all that they both contain the element 1. So 1 will for sure be in the union there. I only write it once though. I also see that 2 appears in the set B, so that'll be there. 3 appears in both, so that will go there. The element the element 4 appears in B. The element 5 appears in A, and then we also have the element 7 in A that we haven't written down yet. So A union B is a set given by the elements 1, 2, 3, 4, 5, 7. And so that gives us the thing inside the parentheses. Next, I'm going to look at what the other set is we're given over here, which is C complement. Figure out what that is. So the set C complement, recall that that means everything in the universal set that is not also in the set C. So looking in the set C contains the elements 3, 4, 6, 7, 9. So the things that are not in that set that are in the universe would be 1 and 2, the element 5, the element 8, and the element 10. So now we've got kind of the two sets that are described in the given problem, and we can actually, with this information, now write our solution. Since we're trying to find where the first set, A union B, intersects, that's what this upside down looking thing stands for, that set C complement. And recall that intersection means what do they have in common. So if we look at the two sets, especially with the elements listed up above, I see that they both contain 1, they both contain 2. I see the element 5 in both, and that's it. So our intersection of these two sets would contain the elements 1, 2, and 5. And that would be our answer. All right, so that's one example. Let's take a look at a different one. Here we're asked to find the set A complement, union with B complement, union with C complement. But we have this in out front. And what that is telling us to do is to figure out what's called the cardinality of the set represented by A complement, union B complement, union C complement. And let me write that so that you can actually read it. The cardinality, which basically means the number of elements in this set. So at the end here, our answer will just be a single number. So to do this, we want to approach it similar to the way we approached the first one. I want to figure out what each of these sets individually is comprised of. So A complement, again, everything in the universal set that's not in the set A. Set A contains the elements 1, 3, 5, 7. So its complement will contain the elements 2, 4, 6, 8, 9, and 10. Next is B complement. Well, the set B contains the numbers 1 through 4, or 1, 2, 3, 4. So the complement would be everything above that, right? So we'd have 5, 6, 7, 8, 9, and 10. And then finally, the set C complement. Set C contains the elements 3, 4, 6, 7, 9. So again, we fill in everything that's not mentioned there. So we'd have 1, 2, 5, 8, and 10. Okay. And then from above, the set that is under consideration, the one we care about, is this A complement union with B complement union with C complement. And so we wanted to figure out what the elements of that are. And again, it's going to be anything that is in any of these sets. We just don't write repeats. So I notice here is 1. I'm going to write these in orange. I see that 2 is in both these two sets, so it goes in there. There's no 3. I see the element 4 in the A complement. 5 is in B complement and C complement. 6 is in A complement and B complement. 7 appears in B complement. 8 is actually in all 3 sets, so it would have been in the intersection. 9 is in A complement and B complement. And then 10 we also see is in every set, so it would have been in the intersection there as well. And so our set A complement union B complement union C complement ends up being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Basically everything except for the element 3. And if we count them up there, I do believe that we would end up with 9 numbers. So the answer up here is 9. So the number of things, or the cardinality of the set A complement union B complement union C complement, is 9, since it contains 9 elements. All right, let's look at similar idea, finding cardinalities, this time with Venn diagrams. And in this case of these Venn diagrams here, these numbers we see, these are not individual elements, because notably we have an 8 up here in the left-hand corner, an 8 down here. So these are not individual elements, but they're actually the number of elements that fall within each of these regions. So for example, if you look at this region, that's not going to show up. You're not going to be able to see that. Let me try this instead. Nope. Okie doke. Let's see, will that show up? There we go. So this area I'm trying to highlight here, in this part of A here, this 3 represents that there are 3 elements in there. We don't know what they are. We just know there are 3 of them. Okay, so let's use this Venn diagram to find the cardinalities indicated on the right. First one asks us for the number of elements in the set B. And in a Venn diagram like this, each set is represented by a circle. And in the case of B, it would be this circle I've just highlighted. And anything that falls within that circle would be within that set. So I see that there are 2 elements here in this part of B, 4 here, 7 here, 6 here. So to find our answer, we would add those numbers together. 2 plus 4 plus 7 plus 6, since I want to know the total number of elements that fall within that circle. If we add those up, I believe we end up with 19. So within the set B, in this case, it's a rather large set, there would be 19 elements. Okay, so let's look at the next one then. So next we are asked to find the number of elements in the set A union with C complement. And we actually, in this case, when we have something like this, compared to what we were doing before, finding the number of elements can actually be simplified some, because with a union in this case, it's mostly going to be like addition, right? Because it's anything that is in either of those 2 sets. So since the first part is A, we know that anything within the circle A is included, since anything in the union means anything in either set. And then the set C complement would be anything outside of C. So anything outside of the circle covered by C. So that would be everything up here. around here and around this red border here. And notice that some of that overlaps with the set A, some notably this 3 and this 2. But then there are a couple of things that don't. There's a 6 here and the 8 here. Okay, so we're not going to double count 3 and 2 when we find the number of elements, but we will include that since it's in both of them. We'll also include that 6 and 8. And then for my total here, I also need to include this 4 and 8, because even though they are inside of C, they are in the set A, which gets included in the union. So to find the number of things here, I'll add all these numbers together. So I have 3 plus 2 plus 4 plus 8 plus the 6 plus the second 8. And I believe if we add all those numbers together, we end up with 31. And so in the set A union C complement, we end up with 31 elements. All right, now for our last example, this one takes it a little bit of a step further. We have the number of elements in A complement intersected with B complement intersected with C complement. And here, I'm again going to do this step by step, though, since we are looking for an intersection now in this problem, okay, notice that we're intersection. In this case, we care where everything overlaps, right? Because remember that an intersection is the total number of elements that sets have in common. So it's, in this case, going to have to be things that are overlaps. So if I look at the first set given in that problem, talks about A complement, which means we'd be looking at everything outside of A. I'm going to highlight that here in this purple highlighter. So in that case, we're just looking at, so far, this 1, this 7, this 6, and this 8. For B complement, we will be looking for everything outside of B. So anything that falls outside of this red circle here, which in our case is going to include the 8 in the upper, and I apologize, I realized I just drew that poorly. So it would include this 1 down here, everything in A that's not also in B, this 8 up here, be along that, inside that red area that I have highlighted. Now notice that the 6 and the 7 there fall within B, so we actually can take those out as candidates for elements in the intersection, okay, because they can't be in B complement. And then finally, we will find the values or the numbers inside C complement, should basically be everything outside of the circle C. Highlight that in green. Okay, which means now this 1 cannot be included in the intersection because it's within C, which leaves us with only one number left, right? This is 8 up here, which hopefully makes sense since it's outside of all 3 circles for A, B, and C. So it would be in the intersection of their complements. So what we find from there is the number of things in A complement intersect B complement intersect C complement is just 8. Okay, that's it for now. Thank you for watching.